Hey everybody, we are going to be working on reflections today. I kind of have to laugh, the title of this thing, Reflections. It's kind of like deep thoughts or something like that, but that's not quite what we're about. We're doing geometric reflections, and we're out of section 9.2 in the book. We're going to talk about reflections and lines of reflection, and you know what? I'm going to start by showing you a whole bunch because I think you know what they are. Here's what we got here. We got our red Yuma. And as we discussed yesterday, this is what we would call the preimage. And if we were to take a line like this line M and basically use that as a mirror so that every point from the preimage over to the image is exactly the same distance. So the distance from this corner to line M is going to be exactly the same distance from line M to this corner in a perpendicular manner, or in other words, M is the perpendicular bisector of any line that connects a point and its corresponding point. So basically, then we get an image, right? So this is kind of an important concept that I'm throwing at you. That any line, let me just choose another color, purple, that I draw from one point to M, and I keep going perpendicular and I draw the same thing, I'm going to find its reflected image over on the other side of the line. Make sense? So same thing's going to happen on this next slide where I move the Yuma, the preimage, farther away from the line of reflection, and same thing holds true. This distance from here to here, perpendicular bisector, same as the distance from M to the corresponding point. And that'll happen on every single point that we got there. If I could draw straight lines, this would really be impressive. But I think you guys get the point. Perpendicular bisector of any line connecting a point with its corresponding point on the new image. All right, that's a reflection. You will see that a reflection could theoretically go straight through an object. All right, so I've got my preimage Yuma in red, reflected it over line M, and the same thing is still going to hold true. Any point that I draw from here to the green line is going to be equally distant from the green line to its reflected image. Okay, so just thought that you would like to see an image reflected over itself. Okay, some other examples. All right, know that M does not have to be vertical. It can be horizontal. It can even be slanted. All right, and in this case, all these things are still holding true. All right, perpendicular bisectors from any point to its corresponding point. Make sense? Makes sense. Absorb those, take a look at them. I thought this one was came out looking kind of cool. Anyway, let's get into our definition now that we've seen. Oh no, there's just a fun one. Can you guess what that says if we do the reflection over the green line? Okay. So, a reflection across a line M, which is called a line of reflection, is a transformation with the following properties. Okay? If a point on the image is on line M, so see point A right there, that is on line M, well, its reflected image would also be on line M. It would be itself. A equals A prime because they are both on the line. Okay? Otherwise, any point is equally distant in a perpendicular line from line M to the original point and to the reflected point. And the way this reads out, if a point is not on line M, then M is the perpendicular bisector of the line that connects a point on the preimage to the image. Okay, in this diagram, M is the perpendicular bisector of B, B prime, and of C, C prime. All right, notice that the letters in our preimage here read counterclockwise. A, B, C. While in the reflected image, notice that they read clockwise. A prime, B prime, C prime. Okay, just kind of an interesting thing. Now, the way we write a reflection rule looks like this. R, big R means reflection. M is the line of reflection that it's going around. Okay, it won't always be M. We'll show you some examples of that later. And then the figure. Triangle ABC, Finally, the final image, triangle A prime, B prime, C prime. That's what our rule looks like. Okay, let's go on to the next slide. Just a quick summary. This is how we write our reflection rule, our notation. Know that distances are all maintained. Okay, every distance in the original pre-image is the same as the distance in the corresponding line in the final image. All angles are maintained. Okay, angle A is congruent to A prime, C is congruent to C prime, B is congruent to B prime. All right, side lengths, angles, are all maintained. Finally, every point on the pre-image maps to one and only one corresponding point on the image. So B has only one matching point, and that's got to be B prime. Okay, this point right here has one and only one matching point. It's got to be same distance, perpendicular bisector. It's got to be somewhere right there. So in other words, if we got a reflection of any point and we want to call it A and it becomes A prime, well, you know what? There's only one way it can work backwards. The reflection of A prime has to go back and be A. Okay? Anyway, it's a one-to-one match between any point on the pre-image and its corresponding point on the image. All right. So, a few examples. Now, notice we didn't write M. We're going to use instead the x-axis. Okay? So, what happens? What are the vertices of the reflection across the x-axis of PQR? So, well, I'm going to take P and looking at the x-axis, which of course is this line right here. Okay? Well, P is 6 units away from the x-axis, and the perpendicular distance would go straight down, so I'm going to go down another 6 units and put my dot right there. Same thing on Q. Q prime will be right here. There's Q prime, P prime, R prime is up 5, so it's got to be across the x-axis, down 5, and we end up, let me clear those clear annotations. Okay, and I'm going to cheat because I've already created a couple little objects up here that are going to help me do this, right? Basically, P prime, Q prime, R prime would be straight down here, and we would end up with our reflection looking like that. Okay, so that's a reflection across the x-axis. What would a reflection across the y-axis look like? Well, same thing, only now I'm going to go across the y-axis, which is right here. Right? This one right here, real ugly, but you see what I'm talking about, y-axis. So I'm going to go straight across from Q to Q prime. I count over 1, over 1. Got it? Got it. From P prime, we're going to go over 3, over 3. And from R prime, looks like I'm over 7, over 7. Okay, and in this case, undo that. In this case, I'm going to end up with a figure that looks like that. P prime, Q prime, R prime, with a reflection over the y-axis. All right, now your book is going to try and fool you some here. Okay, there are annotations again. Okay, what is the reflection over the line y equals 0? Well, hey, you know what? We've already done it. The line y equals 0 is the x-axis. All right, so when we did this one before, got to stop doing that. When we did this one before, hey, this is the same as what we did up here. Okay, remember, the line y equals 0 or the line of reflection over the x-axis are the same thing. Same thing's going to happen down here, guys. The line x equals 0 is, of course, the line x equals 0 is the y-axis. So, just like these were the same, these also are the same. Okay, remember the x-axis and the line x equals 0 are both the y-axis and the line x equals 0 are both this line right here. So we got the same thing listed several different ways. Now I want you to notice, last piece of information is that for a reflection across the x-axis, notice what happens with our coordinates. Every coordinate, p, q, and r, basically became the same value for x. So like r is at negative 7, 5. When we reflected it across the x-axis, we got negative 7, negative 5. P, negative 3, 6 becomes negative 3, negative 6. And Q, negative 1, 3 becomes negative 1, negative 3. Basically, every xy value becomes x, negative y for a rotation or a reflection across the x-axis. Okay? For a reflection across the y-axis, notice we have any coordinate xy becomes negative xy. Negative 1, 3 becomes positive 1, 3. Negative 7, 5 becomes positive 7, 5. And negative 3, 6 becomes positive 3, 6. All right, so we change the signs in a couple of these predictable ways, right? That happens on a reflection across the y-axis. That happens on a reflection across the x-axis. Nice little rule of thumb to always remember. Okay? Clear those off in case you want to pause it, look at them again, make sure you understand. Okay? Now, a little more tricky problems coming here. What are the vertices of this reflection where we use the line y equals 2? Now, I don't want to make this ugly, so I'm going to pick an actual pretty line here. Okay? The line y equals 2 is the line that goes right across here. Okay? So now, again, I've got my cheat thing over here, but I'm going to need to put it at such a point where, well, this is 1 unit above that line. I got to put q prime 1 unit below the line. R is 3 units up. R prime would have to be 3 units down. So it doesn't always just work across the axes. If I choose a line y equals 2, this is what's going to happen, but I'm going to do exactly the same thing. I'm going to count how far above I am, above the line I am, and reflect my image exactly that same distance on the other side of the line. Okay? Now, a couple for you to try, or one for you to try. Let's look at this one. Pause it if you want. I'm moving on without you if you're not. So here we go. We're going to make our line of reflection where x equals negative 3. Let me make it green. X equals negative 3. So here is my line of reflection. Now every point reflects across that line in a predictable way. Okay, so, well, P is on the line. So remember, if a point is on the line, it stays there. It becomes itself. Okay, R is 1, 2, 3, 4 units over. 1, 2, 3, 4 units this way is where I'm going to put R prime. And Q is to the right 2 units, so Q prime has got to go to the left 2 units. Now we can connect those dots, and let me just grab my little cheater here again. And I believe we're going to line it up right like that. Okay? So that's what happens when we do a reflection of that original PRQ, triangle PRQ, across the line x equals 3. 2 more examples for you. Oops. That green thing. Okay, we're not always going to be nice and pretty here. New example. What happens of the line if our line of reflection is the line of y equals x? Well, we better find out where our line of y equals x is. Hope you guys remember this from algebra. Okay, the line y equals x is the one that goes right up like this. So in order to do a reflection across that line of y equals x, I'm basically going to count diagonals now. Okay, I'm going to take Q, and it counts over 2 diagonals before I hit the line. 2 diagonals on the other side. So 2 diagonals over, 2 diagonals down. Here's Q prime. See what I'm doing? For P, count 1, 2, 3, 4, 4.5 diagonals. half, 1, 2, 3, 4 diagonals over here, and we'll have P prime. And finally R, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and I think I got it there. And you're going to see that we're not going to be able to use our blue cheaters there. So what I'm going to do instead is make some blue lines over here. There's Q prime, R prime, P prime. Here's our reflected image across the line y equals x. Now notice this. For a reflection across the line y equals x, every coordinate just basically got flipped around. Q was at -1, 3. Q prime is at 3, -1. R is at -7, 5. R prime is at 5, -7. And same thing with P. Alright, so let me clear off everything again. Actually, let me reset the page. So I'll go back over here. We'll go back down here. Now the line y equals -x. Last thing I want to show you is let's make our line y equals -x. That is this one right here, right? So once again, count diagonals. Let's make our dots here. Make them green this time. Right, over 1. Across there's R prime. P prime. We got 1.5 diagonals. Go over here for P prime. Q, I go over 1 diagonal. Over here, on the other side, Q prime. Connect the dots. We have a figure that looks like this, and this, and this. And there's our reflected image across the line y equals -x. Last rule, when we do a reflection across the line y equals -x, notice that every x value and y value also switch, but they turn into negatives of each other. Okay, so if I start at -1, 3, well, Q prime becomes -3, -1. Okay, or -3, +1 rather. Okay, switch every sign and switch the location of them, and you know where your reflection goes if you reflect across the line y equals x squared. I'll let you go back and look at it on your own. Write a good summary. I'll see you later.